Okay, in this section 4-1, we're starting a new unit, actually, Unit 4. And in 4-1, we're talking about exponential functions. And so we'll begin by defining an exponential function. So an exponential function, f, with base a, is defined to be f of x equals a to the x power. So if x is your exponent, then you've got an exponential function. Of course, the a must be greater than 0, right? And my a also cannot be 1, and then x has to be a real number, right? So from here, we're kind of looking at some of the characteristics of the parent function. So the parent function for exponential would be f of x equals to a to the x power, all right? And so this is really the first function that we've studied where x is the exponent. All right, and so it has a little bit different characteristics than many of the functions that we've studied so far. Okay, and so the graph of f of x, okay, is listed down a to the x power, the exponential function. It's graphed here below, and so we can kind of see the graph of this one. And next to it, we have the graph of f of x equals a to the negative x power. And so we can see that it just kind of flips the function around. Okay? All right. So again, the domain of each one is the same, from negative infinity to positive infinity. All x values are on the function. The range, now remember, the range is the y values. It's from 0 to infinity, again for both. All right. The y-intercept is at 0, 1 for each one. That's your y-intercept. And there is no x-intercept for either of these two. And so for the first one, a to the x power, it's increasing on the interval from negative infinity to positive infinity. So it's increasing on that total interval. However, a to the negative x, it's decreasing over the interval from negative infinity to infinity. And both of them have the x-axis as a horizontal asymptote. And so for a to the x power, a to the x approaches 0 as x approaches negative infinity. All right, so as x approaches negative infinity, then toward negative infinity for your x, that's where the function value itself approaches 0. All right, so that would be the limit. However, when it's flipped, then a to the negative x power approaches 0 as x approaches positive infinity. All right, so it just approaches 0 on different ends of the graph. All right, now let's take a look at one more thing here. If you've got an exponential function whose base is e, then that's called your natural base. All right, so e is a number, right? It's an irrational number, and it's 2.718281 and so on. It's a non-terminating decimal. E is a constant, kind of like pi. So like pi is 3.14, and that decimal keeps going. Well, e is 2.718, and it just keeps going as well. So e is a constant number, very much in the same way that pi is a constant number. Now, you obtain pi by dividing the diameter by the radius. That's how you get pi of a circle, right? Well, the way they get e is from this function. Okay, it's the limit as x approaches infinity of 1 plus 1 over x to the x power. So in this function, as x gets bigger and bigger and approaches infinity, the limit of of this function, that's where your e comes from. So that's how you obtain this number. All right, you could actually plug it into the calculator if you wanted, or graph this and see what happens as the x gets bigger and approaches infinity. You would see that the limit approaches this number e. Okay. And so when you have an exponential function whose base is e, and as a matter of fact, we probably have time to graph it and see it. Let's do that. All right, so I have my calculator here, and let's put this one in there, this function. Y equals, open a set of parentheses, 1 plus, we'll make a fraction here, 1 over x. We're going to come back here, we close it, and we're going to raise that up to the x power. Alright, so there's my graph. Okay, so now if we wanted to take a look at the limit, right, as x approaches infinity, in other words, what's the end behavior on this end, probably the best way to do that would be to add a table to this thing. So let's add a table here. And so what I can do is I can say, okay, what's the value when we get up to 100? All right, 2.70. Well, what if I add another 0, 1,000? 2.169. And oh, you can't see it, so let me bring it up some so that we can see it. Okay, there you go. What happens if I add another 0, 10,000? All right, 7.181, and we're getting a lot closer to this number now. What if I make it 100,000? Let's go like this now and see what we're getting to. So now it's 2.718281, and then so now it kind of matches this number pretty close, right? So again, that's the value of this function at 1 billion, right? And so again, as it approaches infinity, this function, then that's where the number e comes from. All right, so there you go. Okay, so now let's take a look at the types of problems that you're going to be asked to do. And so for this function, 5 to the negative x plus 2, we want to look at this. We want to find the domain, want to find the intercepts, asymptotes, describe end behavior, and give the intervals for increasing and decreasing. So those characteristics that we looked at on the other page, now what we want to do is we want to give those characteristics for this specific exponential function. And it is an exponential function because it is raised to the power of x. Okay? All right. So again, the best way to get all of these characteristics, I would say, is from the graph. And so let's graph this function and see what it gives me. So I will go y equals, it'll be 5. 5 is my base. I want to raise it up now to the negative x power. Come out of it, plus 2. And so there's my graph. All right, so based on the graph, can we find the domain and the range? Well, the answer is yes. Let's think about this for as far as domain is concerned. That would be the x values. Well, for the domain, if I'm writing it in interval notation, let's see what the domain would be here. And probably the best way to verify both ends would be to add a table. And so let's see what happens here. So as I go far, like to negative 1,000, all right, becomes undefined there, but I think that's just because it cannot actually determine it from the calculator. We can't see it there. But in anyways, it keeps going, and so that's already 10 to the 6th power, right? Just at 10. So it increases very quickly, as we can see there. Okay, so it increases without bound exponentially, and there's no lower bound. So it's from negative infinity. Same thing on the positive side. If we go 200, all right, and then it goes up to 2. So there's what we're looking at. It's from negative infinity to infinity. All right. The range is going to be, of course, the y values. And as we can see now from the right hand side, as I put very large numbers in here, like maybe 10,000, all right, we can see that 2 is kind of the limit on this right hand side, so it never goes under 2, as we can look at here also from the graph. And so remember, when you're talking about the range of values, it's on the y part of the axis, and so the lower bound is going to be 2, and then the upper bound, of course, is going to be positive infinity. There's no bound to how high it goes on the axis. Okay, so there we go. That's domain and range. Finding the intercepts now. Once we have the graph, we can do that pretty quickly. We can see there is no x-intercept. However, there is a y-intercept right there at 3. And so if I were writing out both intercepts, I would say x-intercept. There is none. All right, and the y-intercept, I would say, is 3. You could write that out as an ordered pair if you wanted to, 0, 3. Either way would be sufficient. Okay. Find the asymptotes. And so now we can kind of see that there's a horizontal asymptote, and it's going to be right here at y equals 2, as we can see when it's getting big. Now, you might be saying, well, coach, it touches 2. It has the value of 2. Well, that's the only reason why it's displayed as 2 is because the calculator has to estimate at some point. So it's estimating 2 here at 10,000 on the x, right? But really, this is 2.0000000000000000001. So it still never reaches that value, even though the calculator has to estimate that it does, right? So don't let that fool you when you're graphing. The asymptote here is still going to be y equals 2. All right. And describe the end behavior. And so we can look at either end. Let's say that we start by looking at the left end behavior. So the limit as x approaches negative infinity. All right. Limit as x approaches negative infinity of d of x is, and once again by looking at the graph we can see that it is rising up to infinity, right? No limit there on that boundary. And so the limit as x approaches negative infinity for the function is infinity. Now we want to look at the end behavior on the right hand side. So the limit as x approaches infinity of d of x. And again, we've already taken a look at the graph and the values, and we know that as x approaches positive infinity, the limit for that graph, the value of the graph is going to be 2, or the value of the function, I should say, is going to be 2. All right, so we've described the behavior on both ends. On the left-hand side, it goes up to infinity. On the right-hand side, the limit is 2. Okay. Now, I want to give the intervals for increasing and decreasing. And once again, as I look at the graph, I should be able to notice that it's decreasing on the entire domain, which means it's going to be decreasing on the interval from negative infinity to infinity. All right, so there we go. Now we've answered all the questions regarding the characteristics. Okay. Number 2, we have another exponential function, this time with the natural base e. And so let's clear off this graph and we'll start with another one. And so for this one, we need to go ahead and plug it in. And we want to plug in y equals, and we need to find e on this thing. See if we can find it. let's see, ABC. Perhaps what happens if I put in an E? Well, there you go. Oh, you can't see that? And so what I had to do there to get that, let me just start all over since you couldn't really see it. So from here, if we go Y equals, right, and if you click on ABC right here, it'll give you the keyboard. If you just type E, then it reminds you that it knows E as 2.71828, and it reminds you of that there. And so now I can go back to this and raise it up to the power of X and go +2. And I wanted to stay on +2 with my exponent, and it dropped out of there. So let's see if we can do it like this. Oh, we still can't do it. Plus. Well, okay, so you see what's happening here, right? Even though I'm still up in the exponent, as soon as I put a plus in there, it takes me down. And so how do you think I'm going to remedy that? Let's just put the whole exponent in a set of parentheses and see what we get. So that'll be plus 2, and that fixes the situation. So different utilities that you're using, calculators, different calculators and things may input things a little differently, so you just have to be aware of how to input things correctly based on which input device you're using. So be careful with that. -1. And so now we have it inputted correctly, and so this would be the correct graph that we're looking at now. Now we can fill out our questions about the characteristics. Let's go with domain and range. And so domain first. We want to look at this and see if we can figure out the domain. And judging by the graph here, I would say it's from -infinity to +infinity. So no restrictions on the domain here. What about the range? Okay, if we're talking about the range, I know that it looks like there's a limit over here on this left-hand side, and so we need to see if we can determine what that limit is. And of course, we can add a table to get that pretty quickly. Alright, so here we go. So on the left-hand side, we're trying to see what our limit is going to be there. And so if I put in a -10, alright, we're getting close. -100 maybe. Alright, so -1,000. Alright, so it looks like 1 is my limit. Okay. And so we'll say that the range is from -1 because it doesn't go below -1 on the y value for the function. So that's the beginning part of my range. However, it does increase without bound, and so +infinity is the other boundary for the range. Alright, so we got the domain, we got the range. Let's find the intercepts. Alright, let's start with x-intercepts. And we do have an x-intercept this time, right there at -2. And so, again, you can write it as an ordered pair if you like, or you can just put the value. I just put the value this time, either one is fine. And we do have a y-intercept as well. And so my y-intercept is here. And that's 0,6.39, I guess we can round it to 2 places. So I'm going to put 6.39, and there's your y-intercept. Next we need the asymptotes, and of course the asymptote here that we're going to be looking at is going to be y equals, and it's going to be y equals some number, and once again it's going to be y equals what that graph is approaching. From the table we can already tell what that is. It's -1, and so y equals -1. That is the horizontal asymptote here. Okay. All right. So there we go. And of course, vertical asymptote, there is none, right? Because it just doesn't, even though it looks like it may come to a vertical asymptote over here on this side, but if we just kind of look at the values, we can see that that's actually not the case. Because if I put like 10 in there, or it goes really big really quickly. Change that to 100. We see there's no upper bound. It just keeps going up and up and up. In other words, the value keeps, the x value can continue to increase without bound. Okay. Again, let's see. We can now start describing the end behavior. And so the end behavior here, now, we can say from the left-hand side, so we want to know what the limit as x approaches negative infinity of g of x is going to be equal to. And once again, from the graph and the tables, we've already kind of determined this pretty well, that it's going to be -1. And from to the right hand side now, we need the limit as x approaches positive infinity, so as x goes all the way to the right now, of g of x. And of course we know from the graph that increases without bound, and so that's going to be infinity. Alright, so there we go. Now we want the interval for increasing or decreasing, and this particular thing is going to be increasing from negative infinity to positive infinity. It's increasing over the whole domain. Alright, so again, increasing over the entire domain. Alright, so at this point we're ready to take our quiz. We'll be answering the questions regarding the characteristics, very similar to what we've done here in the practice problems. And so we'll be back soon with the next lesson.